Today we're on page 21 of the Chapter 1 to 3 Chemistry 1 packet, and this is going to pertain to the mole roadmap. A mole is a number. The number for a mole is 6.02 times 10 to the 23rd. Okay, so when I say dozen, you think of a dozen, you think of 12. You could have a dozen eggs, but you could have a dozen pencils, a dozen shoes, a dozen anything. So a dozen is 12. A mole is this number, 6.02 10 to the 23rd particles. It's, of course, a very large number. It's a 602 with 21 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I didn't even really fit that on the paper very well. But that's very, very large. Like, you could not count that high in your lifetime. We'll argue about that another time. But if I said you had 1 mole of something, that's how many particles you had. It could be atoms, molecules, formula units. We're going to learn these numbers, these words coming up soon in the year. So this is how many things are in a mole, okay? So this is counting like how many of them you have. 6.02 times 10 to the 23rd. That's a lot. All right, then we could talk about how much does it weigh in grams. That's going to come from the periodic table. So let's suppose we were going to do carbon dioxide. What you have to look at are the atomic masses of each of these elements on the periodic table. So if you have a periodic table handy, just take it out. If not, you can hit pause and find one and then continue. Carbon weighs 12.0 grams, okay, for 1 mole. That's what it weighs. And then oxygen weighs 16 when you round it to tenths grams per mole, but that's 2 of them because there are 2 in the formula. So when you take 2 times 16 is 32 plus 12 equals 44 grams per mole. So that's how much it's going to weigh on a scale. So if you had a scale right here and you put some carbon dioxide on the scale, of course it's a gas, you'd have to trap it, but that's how much it would weigh. It would weigh 44 grams. Every compound or element is going to weigh a different amount because you have to look at the periodic table. All right, lastly, volume of a gas. The volume of a gas is like how much space it takes up in this case. So if you had a box that was 22.4 liters, that's how much space 1 mole would take up at STP, which means 0 Celsius and 1 atmosphere of pressure. Okay, so we're going to talk about how many particles we have, how much it weighs, or how much space it takes up with the mole roadmap. Let's take a look at the first example. 1.5 moles of CO2. So I'm going to use 1.5 moles, and we're going to use conversion factors. So I want to get rid of moles, so that has to go on the bottom. And I'm going to go to grams, that goes on the top. So how many grams are in a mole? That comes from the periodic table. In this case, it was 44. So I'm going to write 44.0 grams. And then you're just going to take 1.5 times that, which hopefully in your head you could do as 66.0 grams of CO2. So we're just doing conversions, but now with mole roadmap. Okay, I'll make this a little smaller so we can go to the next one. It says 1.5 moles of CO2. I want to know how many particles is that? How many? Number of molecules. So again, I'm going to go 1.5 moles of CO2. I want to eliminate moles, and now I want to go to particles. The word is molecules for CO2. And I have to look at my mole roadmap and see, oh, there's 6.02 10 to the 23rd particles in 1 mole. So 6.02 times 10 to the 23rd molecules. And when you do the math for that, it's going to come out to be 9.03 times 10 to the 23rd molecules of CO2. So that's going to be the answer to this problem. And then we're going to continue on with the next one. It asks about liters, volume at STP. So 1.5 moles of CO2. Every problem I give you has to be at STP for now. So there are 22.4 liters per mole. So the answer to this is going to be 33.6 liters of CO2. And lastly, what if we have the liters? So I have 56.0 liters of CO2, and I want to get it into grams. So I want to get rid of liters and go to grams. Well, the liters is always 22.4 moles. And the grams was from the top, we added it up, was 44.0 grams. So now, when you do the math for this, you're going to do 56 times 44 divided by 22.4, and you're going to get an answer of 110. So that's going to be 110 grams of CO2. Now you can do the worksheet for homework.